Okay, I apologize this video didn't work the first time, but let's give it another go with 4.2, so our properties of logs. Okay, as we start off, we're going to start off with just what we call the common log. So, our common log is base 10, and we use it quite frequently, but it's good to know that if you just see something that says like log of x there, that really means log base 10 of x. Okay, the next one we call the natural log, and it is base e. It is for things that are of continuous growth or also exponential growth or decay models. We usually abbreviate it with ln of x, but you can also write it log base e of x is the same thing. ln, I know it seems a little backward for natural log. However, I think it comes from like the Latin and they put the adjective afterwards or something along those lines. Okay, let's take a look at the next one. So we've got some different properties here of logs. First of all, the change of base property. Unfortunately, I do not believe that our calculators will do a base for you, so you've got to know that when you've got log base b of x, you can find that by doing log of x divided by log of b. So common log, like log base 10 of x and log base 10 of b. Or if you prefer, you can also do natural log of x over natural log of b. Okay, let's talk about some inverse properties here. So, let b be a positive number not equal to 1. I'm going to actually start with this second one where it says log base b of b to the x. I feel like my students had a hard time recognizing that should just be x, so I'm going to do a little work over here to the side, and then I think the other one will follow. So, if we think about log base b of b to the x, let's call it y. Then we're saying, hey, b to the y equals b to the x, right? So therefore, think about what we did back in the last one. The base of b cancels, so y has to equal x. Therefore, we can just say this equation is equal to x. The same thing, b raised to the log base b of x will also equal x. They will end up canceling out. Okay, exponent property. Think about something like x to the m raised to the nth power. In that case, what do you do with these exponents? You multiply them. So in this case, when we've got an exponent of m, we're going to bring it out front and multiply it. So m times log base b of x are equivalent statements. And that's because, think about log base b of x, that's really like an exponent. Okay, similarly, if we had like x to the m times x to the n, maybe that'd be better with numbers. So let me see. Like if we did something like x to the second times x to the third, rather than multiplying, like let's say we let this be x to the second and then cubed it, this would be x to the sixth. Rather than multiplying here, we add those two exponents. So we do 2 plus 3, so we end up with x to the fifth. So similarly here, think about what you do with the exponents. We take log base b of u, and we add it to log base b of v. Similarly on the second one, if I do like x to the fifth, divided by x to the fourth, what do you do those exponents? You subtract them. We do 5 minus 4, and we end up with x to the first. So therefore, we're going to subtract log base b of u minus log base b of v. All right, so let's use the change of base property and approximate the logarithm to 5 decimals. So here, we'll do log of 12 divided by log of 3. And it really depends on what calculator you have as to where you find the log button. So feel free to like send me a message or hang out with me on Google Meet, and I'd be happy to show you on yours. But this is approximately 0.96879. Similarly over here, we do log of a tenth divided by log of 4, and we end up with negative 1.66096. Okay, as you're solving these, the problem is last time we were able just to rewrite the base. Like, hey, notice how this has a base of 3, so 3 to some power equals 5. But 3 to the first is 3, and 3 squared is 9. There's no integer power. Well, we get 3 to that power is 5. So therefore, let's use our definition of log. Whether you think about the definition of log by saying, hey, like log base 3 of 5 equals 2 to the x, so you could use that definition, or you think about like taking log base 3 at both sides and having the log base 3 of 3 cancel out, we'll be left with log base 3 of 5 equals 2 to the x, or 2 to the x equals log base 3 of 5. So therefore, if you want to get x all alone, we divide by 2. So x equals log base 3 of 5 all over 2. A lot of times you can just leave it like that, but if you did want to approximate it, you would have to do like log of 5 divided by log of 3. And then I'd recommend just hitting enter, but that is all divided by 2. And then divided by 2 is probably the easiest way to do it in the calculator. When you do that, you get approximately 0.73249. Okay, next one, same idea, but before I can use my definition of log, I've got to get 90 away from the base of 1.2. So I've got to divide both sides by 90. So I get 1.2 raised to the x equals, this ends up being 23.5. So since it's a nice decimal, I'm going to leave it that way and then having a fraction, although you're welcome to leave it in a fraction, which I believe is 47 seconds. Okay, I'm simplifying. So now, once again, whether you use your definition or think about doing log base 1.2 of both sides, up to you. I almost kind of think about doing this, but if you like the definition better, it really doesn't matter. These will end up canceling. We'll get x equals log base 1.2 of 23.5. So when you approximate that, if you needed to, you do log of 23.5 over log of 1.2 equals 17.31556. All right, check out the next video to see